Hello everyone, welcome to the third section of Pandas tutorial. In this section, I'm going to walk you through the fundamental mechanics of interacting with the data, both in series and data frame. First, we are going to practice re-indexing. What is re-indexing? It's an important method in Pandas object. We can create a new object and we can it also gives us the facility to change the indexing. So the re-indexing is the method that comes with the pandas that will help us to change the index anytime during the data processing. Okay, so first let me import pandas. And then I'm going to create an object with some index, assigned index positioning like that. So the object looks like this. Okay, as a data series. It's a series, not a data frame, it's series. To apply a re-index in this series. Okay, so I'm just going to create an object. So apply this re-index method. So if you use tab, and you can see the re-index method is here. And I'm going to change the index here, DBCA, that is the index. So I'm going to change the indexing, new indexing position. I'm going to apply a new indexing position for this object 2. And if you see, I think there is a mistake here. It's a list inside list. So that's why it doesn't recognize. So you can see now the index position got changed. And also you can notice that there were only 4 elements in this series. I added one more extra index here. And you can see in that extra index position, that is not a number. So null value has been assigned in this extra index positioning. So the re-index method, right? Re-index method in pandas has a lot of useful arguments like indexing, limiting levels, copy, like that. There are a lot of useful operations or arguments are there. Okay, you can do this both for series and data. It is available for both series and data frame. So we are going to see some of the methods. It has a lot of useful methods. We are going to see some useful methods which will be really useful for data pre-processing. For example, let's see the fill method, how we can fill the values inside the series. When the series does not have, when this particular element does not have any value, and how we can replace it with some default values by using the fill method. Okay, so let's see that. I'm going to create a new object here. Okay, so object 3 with 3 values and 3 indexes. Okay, so we'll check the object. Okay, now I'm going to call the fill method, fill argument of re-indexing. Okay, so for that, the object name, that is object 3, I'm going to call the re-index method. I'm going to apply the fill method of the fill argument of the re-index method. So as you can see, there are only 3 elements in object 3. I'm going to call the range argument, range function, passing the range function as an argument, so that you can see now I'm going to introduce 6. That means range 6, 0 to 5. That means it creates 5 elements. Already there are only 3 elements, but this range, according to this range, now the indexing is going to be from 0 to 5. There are 6 elements. And for the extra elements, I'm going to use the filling. For that, the attribute name, the argument name is method, and the value of that argument is going to be fill. So let's see how it works. So you can see 0, 1 value is not here. You can see the 1 value is not here. The 1 value, according to this range index, the 1 value has been introduced, and the value is filled with something that is repeated. Okay, the blue will be repeated here, and 2 which already has purple, and for 3, it is getting repeated. And for 4, you have yellow, and for 5, it is getting repeated. So this fill method will help us to fill with the forward fill values. Okay, which fill means forward fill, whatever the forward values that will get filled. Okay, so let's do the reindexing in data frame now. So now let's see how we can apply the reindexing concepts in data frame. Okay, so for that, I'm going to use some of the NumPy concepts. So let me import NumPy. I'm going to create a data frame with some indexes. Okay, so I'm going to create a data frame, and the name of the data frame is going to be frame, and pd.data frame arrange NumPy arrange, because I'm going to use the arrange function of NumPy. So it is going to have 9 elements of shape 3 cross 3. Data frame has rows and columns, right? So the row has ACD as an index value, and the column has this Ohio, Texas, California as an index. So we'll explore, we'll see how this data frame looks like. Okay, you can see index value for row and index value for column. So I'm going to apply reindexing here. So when we do reindexing for data frame, remember we have to give the reindexing values for both rows and column. If we give only one value, one series of value, then that will be by default it will be taken for rows. Okay. For example, I'm going to create another new data frame, and the previous frame is going to be the object for this, and I'm going to call the reindex. Where you can see now I'm passing only one list of one series, one sequence of elements. So by default, it will be taken for row. It will be taken for row. So see how it looks. You can see already we have only 3 row index values. Now, since I added one new index here, you can see by default, it takes null value. It creates a new row with the index value B, but since it doesn't have any value, it will fill that with null values. Okay, so let's do something with the column. Okay, so if you're going to do the reindexing for column, then you have to use the keyword column. But for reindexing in rows, you don't need to use any keyword, because it is by default, it will be taken for row. But when you need to do the reindexing for column in data frame, then you have to use the attribute keyword column. So frame dot, I'm applying the reindexing tab reindex, and you can see I'm going to apply it in columns. So I have to pass the attribute columns, and the column value is going to be the states variable that I have created here. You can see Texas, California, which is already has some values, that values will get replaced. But for the new label, column label Utah, there are no values in frame, right? So it recognizes that and fill that column with null values, not a number, null value. So the same thing, how it works both in series and data frame in the same way, but the only difference is when you work with the column, when you need to work with the column, then you have to use the columns attribute. Other than that, everything else is same. Now we're going to see how to drop the entries from axis in both series and data frame. So first, let's see how to do the dropping in series. Then we'll see how to do it in data frame. So I'm just going to create a new object here. Okay. And you can see the object, the created object here. Okay, this is the object that I have created. Now I'm going to drop this row. Okay, to delete or to drop a row from the series or data frame, you have to use that method called drop. Okay, so object dot cap drop. You can see the drop method is available here, and I simply need to pass the indexing. You can see the object You can see the row has been deleted. Okay. Now let's do few more droppings directly as a list of value. Okay, so I'm just using list, but I'm passing D and then comma C and then close the. You can see after deleting the B, already C has been deleted, right? So now it will delete with this, it will delete the D. It doesn't throw any error that it doesn't, it's not available. It simply check if it is not available, it will just leave and just gives A, B, E re-indexing position. So next we are going to see how to do the dropping in data frame. Same method, you can use drop method. First, let's create a data frame so that we can practice the dropping. So I have just created a data frame and the data frame looks like this with 4 cross 4 column. Okay, 4 rows and 4 column. So let's see how we can use the drop method to delete the column first. No, row first. So you can see that it has the row, has the states, right? So let's delete the rows. So I'm going to delete the Colorado and Ohio by using the drop method. So you can see it just drop method deletes it as it is. But when you need to do the deleting in terms of column, when you need to delete column, then you have to use the argument axis. Okay, you have to pass the axis either one or column, that both will work. For example, here I'm going to delete the column. So I'm going to use axis 1 and the axis 2 is going to get deleted here. Okay. You can either use axis 1 or you can use column. Okay, both will work. For example, let me say axis value is going to be and I'm going to delete 1. So you can see the 1 got deleted here. Okay, so either axis attribute, either you can use this integer value or the string value as columns. Okay, so both will work. Next, I'm going to show you the particular column values. Next, we're going to discuss about indexing, sorting, and filtering operations in Pandas. First, let's see indexing. The indexing in Pandas is similar like Python and NumPy. So it is not going to be new to you. But we're going to see some of the advanced concepts like how by using the, how you can apply the arithmetic operation in indexing, okay, both in series and data frame. Other than this, everything is going to be similar. So how indexing can be applied in normal Python and NumPy, it is same here in Pandas. So first let me create some object to play with these indexing. So this object is the property name, and as usual, like how you can specify the label-based positioning, you can specify it to retrieve values, and also you can specify the indexing, normal Python indexing. So when you say 2 to 4, 0, 1, 2, okay, and then the 4 will not be taken, the previous to 4 value will be taken. So when you get past this, then it will retrieve C and D. You can see it retrieves the C and D. And also you can pass the list of values, list, you can pass the indexing as list, which is pretty common. I'm just specifying a particular value, that is 1 means B and 3 means D. Okay, so we can simply specify the positioning as a list and that will retrieve the value. And also we can specify some operations like a logical operation, comparison operation. We can say where object with the value object is greater than 2. Okay, object greater than 2. You can see, sorry, less than 2. So 0, 1, 2, 3. Less than 2 means A and B will get retrieved. Okay, like that you can even apply some arithmetic operation on indexing. Okay, we'll do one more indexing related operation where we're saying the labels. Okay, not the position, labels. Saying B and C. And we are assigning some values to that. So now let's see what is there in that B and C. You can see we have assigned 5 to B and C. It originally changes the value in the object itself. So the 5 has been assigned to these two indexing positions. You can do the same thing with the position-based indexing as well. Okay. Next, let's do something in data frame. Okay, I'm going to create data frame. Since we are doing operations back and forth, so I created it, but I just dropped it. That's the reason why I'm creating the data frame for every examples. Okay, so now indexing, how the indexing works. It's very simple. You can simply specify particular row or column, it will automatically retrieve the value. So when I say 2, that it will just consider, recognize that that is the column value and just retrieve all the rows that is there assigned with that. Okay, so it can be list of values. I'm passing strings. You can see it retrieves 2, and also you can specify the normal index Python based indexing like this. So it will just retrieve 0 and 1 from the first row. When you're not specifying a particular labels like this, it will by default take it for row. Okay, so when you say :2, then it will take 0 and 1. And now let's say column based arithmetic conditional operations. Okay, data of 3, that is column 3. You can see the column 3. And we're just going to retrieve the values that is greater than 5. Only the values greater than 5. You can see we are applying it based on the values. We are applying the condition not on this indexing value, but on the values of the data. So we are asking in the column which values are greater than 5, just pick those values. You can see how it will be very useful in terms of data pre-processing. You can apply the conditions like this. So in the data frame, in the data set, when there are negligible values, for example, when you have to consider the values which is in negative, you have to remove it from the data set, that you can simply apply these kind of that as a condition here, and that will remove those kind of those data from the data set. Here you can see greater than 5 value only has been displayed. So the OHIO which has 2 has been deleted from the data set. So, and also you can do the Boolean related operations. So when you say data less than 5, in that case, whatever the value that is less than 5 will be true, and whatever the value that is greater than 5 will be false. For example, here only 0, 1, 2, 3, 4. These values are true because it is less than 5, and the other values are false. So when you apply it directly like this, then it will give the Boolean result. And also you can do the assignment operation, like how we have done the assignment operation on series here. Like that, we can do the assignment operation where we can assign the values directly in the data frame. Okay. For example, here I'm saying for the values which is less than 5, instead of having it as less than 5, we can just replace it with zeros. So this will do this job. So which values are less than 5, those values has been replaced with 0 here. So those kind of assignment operation can be done. So next we are going to see how we can do a little bit more arithmetic operation in terms of data alignment. So we are going to practice like when you're adding two objects together, if any index pairs are not same, then the respective index in the result will be like a union of the index pairs. So if you're familiar with the database, if you're familiar with SQL, then you can consider that as an automatic outer join. Okay, so when there is a matching of the index, then only the join will occur. So first let's do it in series, then we'll do it in data frame. So I'm just creating two series. So S1 with the series of these values and this index, and I'm creating S2. Okay, first let me see S1, show the S1, and then so the S2. I'm creating another series with different values. Okay, now when I do the arithmetic operation like this, adding these two objects, what will happen? It will just pick the index that matches. Here the index matches with the A value 7.3 minus 2.1, the arithmetic operation, then it will say minus 7.3 minus 2.1, which is 5.2. And then C values minus 2.5 and plus 3.6, which is 1.1. And then there is no D value, but there is E value, where you can see the E value is 1.5 and minus 1.5, which is 0. For other values like D and F and G, it just takes it as not a null value. We can do the similar kind of operation, the data alignment operation similar to outer join in data frame as also. So let's create a data frame. Okay, and it looks like this. Let's create another object with other values, which looks like this. And let's do some arithmetic operation on these two objects, data frame 1 and data frame 2. You can see wherever the matches, where the match occurs, there and all, you can see the result. And wherever there is, just say not a null. Okay. For example, here, Colorado is not there in the D. Colorado is not there here, right? So it just say not a null for this. But Ohio is here, and but for column, only B is there in data frame 1 and 2. So that says 3.0. And D is there, that also says 5.0. But when there is no C and Ohio C is not here, right, in the data frame 2, and also E is not there in data frame 1. So those values are just getting replaced with null values. Similarly, for Texas, only B and E values will has the match. B and D value has the match. Other values, that is just replaced with null value. So if you add a data frame object with no column or row labels in common, then the result will be all null. Right? That makes sense, right? So if there is no match, then it will be all null. For example, let me create a data frame. Okay, and then another data frame, 3, 4, with a different index. So when I apply some arithmetic operation, I'm just going to do some subtraction. So since there is no matching of index, then it will just produce null for all rows and column values. Okay, so that is about doing data alignment with arithmetic operation in both series and data frame. So next we are going to see how to use LOC and ILOC method to specify the location both in series and data frame. So LOC and ILOC are very useful methods when it comes to real world applications. We'll see one by one. So the LOC and ILOC methods enable you to select a subset of the rows and columns from a data frame with a NumPy notation using either axis labels. For that we will use LOC, or integer labels. For that we will use ILOC. For example, for this data frame that we have created here, which is data, here we'll reuse that data frame since it is not, we didn't delete anything from that. And this is the data frame. Let's reuse this. In this data frame, if you apply LOC. Okay, tab LOC. You can see LOC location. And the parameter we're going to pass here is Colorado, which is the row value, and also the 2 and 3, which is the column value. So how can you specify it? Row value as a first parameter, and the column value, since we want to select 2 columns from the data frame, we are specifying inside the list, inside the parenthesis, inside the square bracket. So you can see now it says from 2 or 4 values. So 3 value for Colorado is 5 and 6. Okay. So this is for location access labels. You can do the same thing for integer labels, that is the position-based labeling. Okay. For example, let's do the same thing for position-based labeling. For that, you have to use ILOC. Row, I want to select the row value as 2, which is 0, 1, 2. And then in column, I want to select 3, 0, 1. See, you can change the orders. Okay. So this is third index, 0 index, and first index. You can see in UTA, it is going to be 3. 3 means 4, and 0 is 1, and 2 is, this 1 is 2. So you can see it just retrieves 8, 9, 11, 8, 9. So you can see how convenient it is. You can just retrieve the values in any order with any kind of indexing. Okay. So we'll see some more of these kind of indexing. If you want to select all the rows, for example, it's very easy to select all the rows from all the columns from the particular row. You can see that row values is 2, and that is 0, 1, 2, and it just retrieves all the values. Next, you can see from 1 and 2, 3, 0, 1 position. With that, it can just retrieve all the values like this. Okay, so we'll do some more of this location-based indexing, access-based indexing for all the rows and columns. Sorry, all the rows, all the columns in the row UTA and 2. Okay, so the row is UTA and the column is 2. So the value is 9. Location UTA, Ohio, Colorado, UTA, and 9. Okay, so all the it's saying that from the until UTA, all the values in the column 2. So until UTA means this 0, 1, and then including that. So it is 0, 5, 9. Okay, so as we have seen before in the indexing, we can also apply the arithmetic conditional operation here. So data dot ILOC, that is integer based location, all rows, comma, columns until 3. And even we are applying in the data where the column is 3 greater than 5, all the values which is greater than 5. So you can see the result. So it just get the values which is greater than 5. You can see it takes all the rows, and in terms of columns, it takes only the first 3 columns, leaving the last one, and just consider the values which is greater than 5. So it just excluded Ohio because it just has 0. So it excluded that according to this condition. Then it just include the other rows. Okay, so like this, you can perform any kind of filtering operation with the ILOC. You can just apply the filtering condition like this in any kind of format, in any combination of conditioning. Okay, it can be the logical conditioning or filtering with rows, columns, with position based or location based. So this is kind of filtering operations that you can apply using Pandas. So next we're going to see how we can fill the values using arithmetic operation or any kind of possible things like you can just fill the value, numerical value or default value or the value of the other object, other data frame. So how to fill the values, missing values. Okay, what are the options? We'll see that. For that, first, let's create a data frame, df1. Let's create another data frame, df2. Okay, so you can look at the value A, B, C, D, and AB. So it has one less rows and one less columns, df1. Okay, now what we're going to do, we are going to use the LOC method, that's position based, where the row value is 1 and the column value, we are just taking the B. Okay, so you can consider in df2, 1 column value B. This is 6. So here we are going to change the value. We can assign any value. For a difference, I'm going to assign not a number using NumPy. So we have already imported NumPy here. So I'm just deleting the value, which is 9 here. I'm just going to replace it with not a number. Okay, this is kind of filling by assignment. So you can see this value has been changed to not a number. With this, if I'm adding this object 1 and data frame 1 and data frame 2, with simple addition, you can see we have already discussed this, right? When there is no matching, then it will just say not a number. So the E is not there in DF1 and 3 is not there in DF1 because DF1 doesn't have E and 3. So it will just replace everything with not a number. So now I'm planning to fill. I want to fill this with instead of not a number, I want to fill with other values. How can you do that? Using an add method on df1, I pass df2 and an argument called fill value. Okay, the add is the method which comes with data frame. For example, let me say df1 dot tab. You can see add. So we can use this add method to fill the values. You can either use assignment or add method or method with the fffill. There are multiple ways you can do the filling. Fill value. I'm going to use fill value and I'm going to fill it with 0. Fill value with 0. Let's see what it does. So you can see when I have the fill value 0, then what will happen? In df1, all the values of df2 has been added. So the df2 is 9, 14, 19, and 3, everything, whatever is there in df2 has been added to df1 as well. Okay, so this is the add method, result of add method. Each of the arithmetic has a counterpart starting with the letter R. Okay, so for example, if I divide 1 divided by df1, so all the values will be divided by, for example, the first value for a and 0 in df1 is 0, then 1 by 0, it gives infinity. So the counterpart of that is reverse. Okay, so that can be done by df dot reverse of division. Okay, division by 1. df1, reverse of df1. So you can see that same operation you can do it like this or using the OR div method. Okay. So next we're going to see arithmetic operation between series and data frame. How we can work on the series and data frame together in the same time. For that, first let's create an array using NumPy. Okay, array method. Sorry. And then let's retrieve the values here. For example, the 0 indexing of array. So if I subtract You can see it just do the subtraction in the same. This is normal, right? In NumPy, this kind of operation is pretty normal. How to do the same kind of operation in data frame? That's what we are going to see. Okay. So in NumPy, you can just take a. It's nothing but this is a multiple 2D array, and how you can subtract a 1D array from the 2D array. It's pretty easy, straightforward. The same thing can be done. In data frame is nothing but 2D array, in series nothing but 1D array, right? Same similar kind of operation should be possible in data frame as well. Okay, so let's create a data frame here. And then let's create a series here. Let's take one particular location, the 0 row indexing. So the UTA is going to be the series. So we are just taking this 2D array, that is the data frame, and first row of that 2D array, that is the 0 indexing, which is the values of the UTA. So that is this first column, which will be series. So now let's do the same kind of operation that we have done in that 2D to 1D. Let's do that on data frame to series. So if I subtract the series from the data frame, then you can see 0 minus 0, and then 1 minus 1, 2 minus 2, which will be 0. The other values will be same, okay, without, there is no change in the other values. If an index value is not found in either data frames columns or series index, then the object will be re-indexed to form a union kind of operation. For example, let me create a series here, and I name that as a variable series2. So if I do some arithmetic operation addition here, so with the data frame and this newly created series. So if I add these two, a frame, data frame, and a series, you can see the result. When there are no values, because this value D is not, F is not there, so it will just create not a number. Okay, so that will create it with null values. Okay, so similarly, you can do the indexing as well. For example, I'm just creating a new series and name it as series variable series 3. And I'm just going to assign the column value D inside this. Okay, so all the values in the column D will be assigned with the series 3. Let's check. Series 3, you can see all the values in the D. 1, 4, 7, 10. You can see here 1, 4, 7, 10. So that will be assigned as a series here. You can do the same thing by using the subtraction method, like how we use the add method here, like that we can use the method called subtraction in the data frame dot tab. You can see there is a method called sub. Then I'm passing this newly created series 3 variable and axis. Remember the axis thing, we can specify one or column value here. I'm going to specify index. What is the index? That is BEF, which is the variable. So you can see the subtraction will just do the subtraction of series with these indexing position. Okay, that is BDE, that will be subtracted from the series value. Series value is 147. So with that subtraction, the result will be this. Okay, so that is about how to apply arithmetic operation and fill the values, and how to apply arithmetic operation between frame, data frame, and series. Next, we are going to see how to do mapping. So next, we are going to see how to apply the NumPy U functions like absolute function, minimum, maximum, all like you might have you review U function section that we have discussed in NumPy tutorial. So how to use those kind of functions in Pandas? Let's see that. So it's like element-wise operation. How we can perform U function is nothing but the element-wise operations. So how to apply element-wise array methods in Pandas. Okay, so that is it will not work by row or column wise. Instead, it will work based on the elements. So first, let's create a data frame for this. Okay, look at the frame that we have created. Okay, let's use the element-wise operation called absolute. Okay, in each element, how I'm just using NumPy on Pandas because remember, Pandas is built on the NumPy, so you can apply all the methods that you can do it in NumPy can be done on Pandas as well. So you can see the absolute will change all the negative value to positive value. Okay, the absolute function has been applied on frame, so all the negative value has been converted to positive value. So let's create a lambda function. Okay, to perform a little bit advanced, not advanced, but a little bit more functionality. So here what I have done, I compute the difference between the maximum and minimum of a series. Okay, so it is going to be invoked on each column of the data frame. So let's see the result. So here I'm explaining the function again. So default function, it didn't name the function. It is some temporary function. So what it will do, it will perform the maximum and minimum value of the data frame and compute the difference between the maximum and minimum value in terms of element wise. Okay, so this is the function that I have created. How I can apply it on this data frame? For that, you have to use the method called apply dot tag, and you can see there is a method called apply. You can just use this apply. And what is the method that you want to apply? F, which we have defined here. So if you apply here, then you can see it will bring everything in each column, B, D, E, in terms of column. If you want to do it in row, then you can specify it with a row. Okay, let's see the same thing, how you can do it with the row. Frame dot apply F, and you have to specify the parameter. Remember, the parameter either axis can be 1 or axis can be columns. Okay, I'm just going to do columns. So now we can see everything is applied on rows. Okay, on each row. So this function passed to apply need not return the scalar value. It can also return series with multiple values. Okay, for example, I'm going to define another function. Define a function, and it is going to return max and min like this. So if I apply this F on frame now, frame dot apply F, you can see it will return max and minimum value. We can even do formatting. Element-wise Python function can be used for, like, if you want to compute a formatted string with each floating point value. For example, if you want to do the format, we don't want to display all values given here in the decimal. Instead, we want to display only 2 decimal value. Then how can we do that? I'm creating a temporary formatting function with lambda. Okay, this is 2 decimal formatting. And then frame dot, here I'm going to use apply map. I'll explain what the apply map will do. So you can see apply map function used to apply a function on a data frame in element wise. For example, here we have done this function, the function, temporary function that we have created here will do the formatting of 2 decimal value. So when you apply it on this data frame, this function on a data frame, that will apply, that will work on the values in element wise, and all the values will be just displayed with only 2 decimal locations. So you can see here it is 0.768. Since it is 8, then it will just change it to 0.77. It will just normalize the value and display only the 2 decimal values. Okay, so that is what the format applying map will do. Okay, so you can even do that on each column separately. For example, frame, and I'm going to do E and map format. So we have done it only for that particular column element. Okay, so that is about applying application of mapping. Okay, by how to use apply method and apply map method to perform element-wise operations. Next, we are going to discuss sorting and ranking. So next, we are going to discuss about sorting and ranking, how to do the sorting in series and data frame, and how to do the ranking. So first, let's create it. Let's do the sorting on series first. Let's create a series. Name it as object. And if you use sort index method, then it will just sort the index based on the alphabetical or numerical value, whatever you pass based on the indexing type, it will just sort it. Okay, the sort index method will help you to sort the data set. Okay, data frame or a data set, you can see. Let's do the same thing in the data frame. Okay, I'm creating a data frame and applying the sort index method. Frame dot tab. You can search for the tab sort index. You can see that here. And here, when you do the sort index, generally on data frame, you can see the result. It's like maybe first I will just display the data frame DABC. And then when I say sort index, it just do that indexing, sorting based on the index. So 3, 1, now that got sorted as 1, 3, okay, alphabetical. If you want to do the sorting in terms of column, then you have to use axis. As we know, you have to do the axis. So axis parameter. So sort index method, instead that you have to pass the parameter, axis equal to 1, or you can specify columns, both will work. Now you can see it sort the index based on the column. DABC has been converted as ABC. Okay, so even you can do the reverse sorting. Sorting in the descending order is also possible. For that, you have to use the ascending equal to false. The ascending parameter, setting it as false, will just sort it in descending order. Okay. Okay, so sorting by values. Okay, that is also possible. Not only on index, you can even sort by values in the data set. For example, here, first let's do it on series. I'm just creating a series. Object dot, for that you have to use sort values. You can see sort index like that. You can see the sort values method, and you can just pass it on this object. So then you can see it has been sorted based on the value -3247. Okay. Let's do on multiple values where it has the not number value, where it has null value in it. Okay, let's apply it. Maybe first let me show the created series. You can see it has not a number values. Now I am going to apply sort values on that. Simply, you can see descending order, not a number, null value will go to the last position. Okay, not in the initial position. The null value will be assigned as a last position. Let's do the same thing in data frame. Okay, I have created data frame, and now we are going to sort by values, but we have to specify which column we want to sort. Okay. So for that, you have to use the parameter called by equal to B. So not by A, we're going to sort it only by B. So you can see now -3, 2, 7, 4 like that according value, the values of all the values according to this value, it will get sorted according to this sorting. Okay. So -3 associated with 0, 2 associated with 1, 4 associated with 0. All those things will get sorted. Even if we can sort it with 2 columns. Sort by, when you say A and B, then -3. But after that, since it will just check both values. When you say 2 columns sorting, it will not only check one value, it will check 2 values. For example, here, when you check the sorting by only B, 2 and 1 will be taken. But when you do for both, when you consider both columns, then the 2 is 1. So comparing to that, the 0 will be lesser. Okay, so 4, 0, and then 2, 1, and 7, 1. So it will just consider all the values. And then it will sort it accordingly. So that is about sorting, how to do the sorting both on series and data frame. Now let's see how to work on ranking. So next we are going to see about ranking, how to perform ranking in series and pandas, series and data frame. So what is this ranking method? So ranking method used to compute numerical data ranks, okay, along the axis. By default, equal values are assigned a rank that is average of the ranks of the given values. There are multiple methods. And also you can specify the attributes like parameters like axis and method, numeric only, those kind of attributes are there, parameters are there. So the axis parameter, you can specify the ranking based on the column or row. If you are applying the ranking on data frame, then you can specify whether the ranking needs to be done in terms of column or row. 0 means row and 1 means column. Method is the parameter which specifies how to rank the group of records that have the same value. So average means the average rank of the group will be taken. The min method will take the lowest rank in the group. Max will take the highest rank in the group. The first method will rank based on the order in which they appear. Okay, based on the ranking will be given. Okay, so let's see some examples. I'm just going to create an object. Look at this object. Okay, so if I apply the rank on this object, you can see 7, 6.5, and the -1 start with the lowest value start with the 1.0, and the next highest 2.0, and the 2 3.0, and then 4. It's like since it can see there are 2 values, so it shares 4.5, 4.5, and then 5, and then for this 7 it is 6.5, 6.5 because 2 values share it. And if you want to use one of those methods, maybe you can refer this W3 school page for further reading. You can see the methods: average, mean, max, first, rank. There are multiple methods that deals with when 2 numbers have the same value, how to deal with it. For example, here we have 2 values that 4 and 4 is that 7 and 7 appears 2 times. In that case, when we apply the method called first, what will happen? It will just rank it based on the like how preference in appearing, like how in the placement based on the placement. For example, here this appears first and this appears next. Based on that placement, it will order it. For example, let's verify this rank. And we're going to apply the method attribute where there are multiple ways of the average, first, min, max. We're going to do the first one, and accordingly, we can see the first value will be taken 6 and the second value will be taken 7. And here, the first value will be given 4 and the second value will be given 5. Okay, by default, it will take the average. And let's do max method and see how it works. We also can do the ranking in terms of ascending. For that, we have to say ascending false, sorry, descending. So for that, we have to say the ascending false. Okay, you can see the max value, which will be the maximum value. So this 7 takes 2, and this 1.0 means, yeah, -5. -5 takes the later last, that is the last small value, right? That is descending order, it is 7. Okay. So let's do the same thing in data frame and see how it works. Let's create a data frame. Okay. And then let's do the ranking based on the columns. Remember, when you do the ranking on the data frame, you have to specify in which axis you want to perform. Axis 1 means column. By default, it is row axis. So you can even specify 1 or columns. Okay, you can see I just do the ranking based on the column. Okay, so this is first, this is second, and this is third. And here, this is first, and this is second, and this is third. And here, this is first, this is second, and this is third. You can see the ranking here. Okay, so you can do the same thing for row. By default, it is row. Ranking will be done by row if you don't pass any parameter. So you can see by default, it does it by rows. Okay, next, we're going to see how to apply, like how to check the uniqueness. Okay, duplicate label, how to perform duplicating labels. So this actually, this particular function methodology is unique method. This will help us to find out the duplication in the data set. I'm going to create a data series with duplication. Okay, the AAA index with any range of values, the indexes are getting duplicated here. And it looks like this, the series looks like this with there is no duplication in terms of values, but there is duplication in terms of index. Okay, so we are going to check whether object dot index dot tab is unique. You can see there should be, yeah, yes, Boolean, yes, floating. You can check multiple things. I'm going to check whether it is unique. Okay. Not a, that is attribute. So you can see when I run this, it is false because the index is not unique. There is a duplication. The same thing you can do with the values. Okay. When there are two indexes, how it deals with that? When you specify you want to retrieve index A, then it will just retrieve both values. Okay. So let's do the same kind of things, how we can, when we have it, same kind of duplication of indexings that in data frame, how to deal with that. For example, you can see multiple duplication of indexing. So when you need to pull up particular row, for example, B here, it will pull 2 rows. Okay, sorry, I have to use the location identification. I didn't use any method. I have to say, since it is location based, access based, I have to use LOC. Okay, LOC. Okay, so the next one, compared with similar method, like in NumPy, we have seen like the arrays comparison. How we have handled missing value in the data. Let's do the same thing in Pandas. Okay, there are missing values. The sum method, it's called sum method here. You see, df dot tab. You can see the method called sum. And in terms of axis, You can see 1.40 here. For the B, it is 7.10 minus 4.5, which is 2.0. Here, not a number, so it is taken as 0, and here it is 5.5. Okay, so we can apply other element wise operation. Let's mean in terms of column. Okay, whether we need to skip the not a number, we can even specify that. When you want to skip the not a number, skip it, then you can say skip parameter, skip not a number parameter. That will not replace it with 0, simply it will say not a number. Okay, so this one to find a mean value. And okay, so if you want to keep including not a number, if you want to keep it as null, then you can say def.me access columns, or you can say access 1. So you can see when there is, we didn't specify not a number here. Okay, here when 1.40 and not a number, it will just take the 1.40. But when both values are null, then it will just take it as not a number. Okay. Similarly, ID max, ID minimum return indirect, like index value based maximum and minimum. For example, in the same data frame, if I use ID max, then in terms of ID, what is the maximum one? That's no attribute max. Sorry, it is IDX max to specify index based maximum. IDX max. Okay, B and D. Similarly, you can do IDX min. DF IDX min. Okay, so minimum value 1. Cumulative summation. You can even do the cumulative summation of all the values. Okay, and then a very useful method called describe that will specify the overall analysis of the data set. Count, mean value, standard deviation, minimum. So it's going to be very useful function when it comes to the real world analysis. df.describe will specify all the values, count, mean, standard deviation, minimum, maximum. Okay, in the given data set, the general analysis, statistical analysis can be done directly by using a single calling method. Describe method will do the job for us. Let's create one more series here and perform the describe on that. Okay, let's see how it looks. Okay, simply a series with the range and multiply it with multiply it 4 times. Okay, if I apply describe method on this, you can see 16 times, unique value 3, and top starts with A, and the frequency of occurrences is 8. Okay, so those are some common methodology like mean, sum, cumulative sum, index-based minimum, index-based maximum, describe. So the commonly used functions that you can use in data frame and series. So next we are going to see how to do some more analysis based on the count, number of time it appears. Okay, so count, unique values, and membership. How to work on that. To explore that, I'm just going to create an object, and in this object, I'm just going to find out the unique values. How many unique values? Like a set. Okay, set in Python. Object dot unique method will do this for us. Okay, so let's display the units. You can see A, B, C, D. It's like similar to set in Python. Okay, how many times each value appears? Okay, that can be calculated by using the method called value counts. Okay, Simply you can pass it. So how many times each value appears, that can be created as a data frame, sorry, series. And then you can even, okay, when you normally do this, it will just give the value based on the sorting. Okay, C appears 3 times, A appears 3 times, and 2 appears 1 time, like that. It will sort the value based on the number of times it appears. If you don't want to do the sorting, then you can say sorting false, so that based on the occurrences, it will specify how many times each value appear. Okay, so next method that we're going to practice is called isIn. IsIn performs a vectorized set membership check that can be useful in filtering a data set down to a subset of values in series or column, okay, in a particular data frame. For example, let's print the object, okay. You can see this is how it appears here. And we're going to apply a mask by using this isIn person. Okay, object dot isIn. Check whether the function isIn function. And what we are going to check, we're going to check B and then C. Okay. So it will just, so we have just created the mask with B and C value. Okay, so now we are going to apply the mask on the bus. Okay, it's like if you know the digital image processing, you can see that applying the mask on the pixel. In the same data, we are applying mask. Okay, so with B and C value, we are just creating a kernel kind of mask. And when you apply this mask here, you can see C is 0 and B appears 2 times with value 5, 6, and C appears index 7 and 8 2 times. Okay, so let's create one more series here. We are going to apply indexer, get indexer method. Okay, so let's say another variable with that index, another series with unique values. Now, what we are going to do, we're going to apply this index method with values. You can pass it as a variable, and we're going to apply it on get indexer method. Specify tab get indexer. You see, get indexer method. And for this get indexer, I'm going to pass this to match. Okay, so you can see wherever there is a match occurs, that it will say 0, 2, 1, 0, 2, 1. Based on this index position, it is 0, and this is 1, and this is 2. So it will say 0, 2, 1, 1, 0, 2, right? So you can even specify like the indexing as a separate variable, and then you can find out the get index. You can apply this indexing, list of indexing on a data set, and then it will just specify in which position those values occurs. Okay, the indexing of that position. Okay, so in real world scenario, you can apply it for the classification. In terms of classification, you can perform the classification based on the indexing. Okay. Let's do some of this value. So we have just applied this value count, everything in series. Let's do the same kind of operation in data frame with multiple columns. Okay, so I have just created a data frame as a, okay, so with key dictionary. And what I'm going to do, I'm going to use the apply function. It's kind of a little bit more complex, like advanced operation. I'm going to apply data. Remember the apply function that we have used. What I'm going to apply, a method which is available. It's not a function that I have created, a method. What is the method? Value count method. Okay. So you can even call this value counts, which is from Pandas library. And then on that, I'm just going to use the fill method. Okay, tab fill NA as 0. What happens? Okay, so whatever the value, everything that has the repetition that will be here, the row labels in the result are the distinct values occurring in all of the columns. Occurring in all of the columns. These values are the respective counts of these values in each column. Respective counts, how many times it appears in each column. Respective counts in each column. Okay, that's how we can. So actually, the value count, what it will do, it written a series containing a unique values as its index and frequencies as its values. Okay, so it will just give the count. Okay, order count in descending order. Normally, if you have to set it in ascending order, then you have to change the values, but you can refer the parameter. So this using method, get indexer method, unique method, and value counts method that we have seen here, get indexer, unique, using, and value counts. These are some popular methods that will help us to find out the uniqueness of the object. Okay, so in this third section of video tutorial of Pandas, we have discussed a lot of operations. We'll do a small review on what we have discussed so far. Maybe I'll pull my tutorial. So first we have started with reindexing. Okay, how to do the reindexing? We have done it both on series and pandas. Then we have seen what are the filling method we can use and how to delete the series or row, a particular row or column from the data frame or series from the particular row from the series, and then how to do the indexing, different kind of arithmetic operations that is combined, arithmetic and conditional operation that is combined with the indexing, and then how to do the data alignment like inner join or outer join like database kind of operation, how to use LOC and ILOC method for the indexing, and then arithmetic operations between series and data frame to perform that, and what is called function mapping, application of function and mapping in series and data frame. And then we discussed about sorting, different kind of sorting operations in series and data frame, and ranking. Okay, so what are the different methods available in ranking, and then how to deal with the duplication of data, and what are the methods that default method, built-in method that we can use for perform analysis, and describe method, some useful methods that comes with pandas, and then how to use unique value count, and get indexer method, okay, for performing data analysis. So that is about section 3. So with this, chapter 5 is over. The next video tutorial, we're going to discuss chapter 6, how to load the data from different file formats. Thank you.